Welcome back students to our geometry class. Let's continue chapter 5, part 2, and let's begin with practice set 5.1. Now let's begin with practice set 5.1. In our last video, we have studied the different formulas which we will require to find the distance between any 2 points, whether they are on the axis, whether they are in the xy plane, okay, whether the line formed or the segment formed by joining those 2 points is parallel to any one of the axis, or whether we have to find the distance between the origin and any point on the axis or in the xy plane. Okay, so the first sum here in practice set 5.1, we have to find the distance between each of the following pairs of points. Okay, now here there are 6 sums. Out of that, I will be doing few sums, and the remaining sums from these 6 sums will be for homework. So let's begin. Now the first sum is, they have given 2 points, point A. The coordinates of point A are 2 and 3, and coordinates of point B are 4 and 1. And as we know that the first thing what is written in that point is the x coordinate, and the second is the y coordinate. So here in point A, the x coordinate is 2, y coordinate is 3, and in point B, the x coordinate is 4 and y coordinate is 1. Now if we have to find the distance between these 2 points, we have to use the distance formula. Okay, so let us assume, it is very important that you use the correct formula. Okay, and as in the formula we have x1, x2 and y1, y2. Okay, so we will assume or suppose the coordinates of point A are x1, y1 and point B are x2, y2. That means this we have taken as x1, y1, and this we have taken as x2 and y2 in the formula. Okay, now it is not necessary that you write this every time. Okay, so if it is a simple sum where you just have to find the distance, okay, then you can write. But sometimes there are sums in which you have to do lot of things, like here only 2 points are given. There are sums where you have 4 points. Okay, and in that case you can do it directly. I will show you when we are solving those sums. But when it is a case of only 2 sums, in that case you can assume x1, y1 and x2, y2. Okay, so we have assumed here. So here even it is written that what is x1? x1 is 2, y1 is 3, x2 is 4 and y2 is 1. Okay, so if you are assuming like this, it is important to mention after that by distance formula. We have already studied distance formula. As I told you that you need to write all the formulas in your notebook, and you need to revise them. Okay, so here distance AB is equal to square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now as we already know what we are going to substitute as x1, y1, x2, y2, we will do the same. So the second step will be just substituting. So 4 minus 2 plus 1 minus 3 the whole square. Next step is to solve. So the root remains the same. 4 minus 2 is 2 square plus 1 minus 3. Now this is simple integers. So 1 minus 3 is minus 2 the whole square. Now we have to solve this square, that is 2 2s are 4 plus. Now negative square is always positive. So negative square, here it has come positive, and 2 square is 4. 4 plus 4 is 8. So root 8. Now always when you get a root and a number, try to split that number in the form of a square, multiple of a square, multiple with a square. So can we split 8 along with any square? Yes, 4 2s are 8. 4 is a square of 2. Okay, so here you can see that 8, how 8 has been split as 4 into 2. Okay, and then 4 comes out as 2 because square root of 4, root 4 is 2. So here this 4 comes out as 2 and root 2 remains the same. So 2 root 2 is the distance AB. Do not write centimeter, meter. If you want, you can just mention units. Okay. I hope it is clear. Okay. Therefore, you make sure that you write the final statement. Distance between point A and B is 2 root 2. This will be your final statement. Moving to the next sum, that is the second sum. So here this will be solving. Same method. As I told you, if there are only 2 points, it is necessary that you mention what is x1, y1, x2, y2. So same, suppose the coordinates, now the points are changed here, of point P are x1, y1 and point Q are x2, y2. Okay, in this case, if we have assumed P as x1, y1, Q as x2, y2, x1 will be -5 and y1 will be 7 and x2 will be -1 and y2 will be 3. Okay, therefore by distance formula, it is important that which formula we are using we need to write, because there are many other formulas also. As we go further, you will come to know. So you need to mention that which formula you are using before writing the formula. So by distance formula, if we have to find distance PQ you have studied also in the 9th standard how to write. Okay, so we have to find the distance between P and Q. So it is written P and Q with a comma in between. First we write the formula. Never start substituting directly. It is always, not only in this lesson, in any lesson, if you are using any formula, see that you don't substitute it directly, but it is very important to write the formula. Maybe that formula you have to use in the sum maybe 4 times, 5 times, but every time you need to mention the formula. So this is the formula as we have assumed. What is x2? So x2 is -1. Be careful when you are putting substituting. See that you also write the correct sign. So x2 -1 minus x1. x1 is -5. So in bracket I will put -5 and this I will give a bigger bracket. Okay. Instead of putting both the brackets same. So x2 minus x1. x1 is this. The whole square plus. Now y2. y2 is 3 minus y1 is 7. The whole square. Okay. Now we need to first solve with the brackets. First the inside bracket. So -1, let it be. Minus into minus is plus. We can solve this. 3 minus 7 is -4. Okay, these are simple integers. Okay, now here. So here again integers, -1 plus 5 is +4. The whole square plus -4 the whole square. Okay. Now you can see here. Now we will proceed. Okay, we continue here. Okay, so the next step here is +4 the whole square. Positive square is positive and 4 square is 16 plus. Now negative square is also positive. Okay, so this will remain positive. 4 square is 16. I have not mentioned negative here. I just explained that you have studied this in the 7th standard also, that a square of a negative number is always positive. So minus into minus is plus. So I have not mentioned here again. Okay, now 16 plus 16 is 32. As I told you that we need to split inside the square root, whether we are getting a multiple of any square. So can we split 32 in the multiple where we are getting a squares? Yes, 16 twos are. 16 is the square of 4. So if 16 multiplied by 2, we are getting 32. Okay, so try. If you are not getting, then you have to leave it. Okay, if you are not getting any multiple such that you will get a square, then you just have to leave it. But if you are getting a multiple, you can split that number with any square. So please do it. Now root 16 is 4. So it will come out as 4 here. And this root 2 remains as it is. Okay. So therefore, as I told you, your final statement, the distance between point P and Q is 4 root 2. Okay, I will show you the full sum maybe here. As you can see here, this was the starting part where we began with the formula. Okay, and then we continued with the calculation. And then the final statement. Okay, as I told you, I will not be doing all the sums. There are 6 sums. 2 I have already done, first and the second. The third, fourth and fifth are for homework. That is, you are going to do it by your own. It is simple and it is same method, only the figures are changed. Okay, so I am doing the 6th sum where they have given a fraction also. So the 2 points W and X, where the first point is minus 7 upon 2 and 4, and the second point is 11 and 4. So same thing we'll first assume. So let's suppose that the coordinates are W of W are x1, y1, and of point X are x2, y2. Okay, where x1 is equal to minus 7 upon 2 and y1 is equal to 4, x2 is equal to 11 and y2 is equal to 4. Now by distance formula, okay, we use the distance formula x2 minus x1 the whole square plus y2 minus y1 the whole square. Since it's a fraction, see that you be little careful while substituting. So here square root of 11 x2 minus x1 the whole square plus y2 minus y1 the whole square. So square root of, now first as I told you that, so try to solve the inside bracket. So minus into minus is plus. Let this bracket be as it is, square. 4 minus 4 is 0 square. Okay. Now 0 square is 0. So this we'll solve in the next. First we try to solve this. It's a whole number with a fraction. So we need to make the denominators same. We cannot add otherwise. So in order to make the denominators same, we multiply 2 in the numerator and denominator of 11. Okay. So and then we add. So I have written directly here. So it is 29 upon 2. I hope you know this calculation. That is 11 has 1 in the denominator. So in order to make the denominator same 2, I multiply 2 here, we multiply 2 here. So it is 22 upon 2. So 22 plus 7 upon 2 is 29 upon 2. Now, square root of anything we add with a 0 square is 0. And anything we add with a 0 is the same number. So we get this. So we leave the 0. Okay. Now, next. Square and square root gets cancelled. So here the square and square root gets cancelled and we get this number 29 upon 2, which further we by division method we calculate and we get 14.5. Now this is the distance between point W and X. So distance between point W and X is 14.5. It can be a decimal also since it's a distance. Okay. Now in the second sum, determine whether the points are collinear. So here again there are 4 sums, out of which I will do only the first and the third. Second and fourth will be for homework. That is, you all have to do by your own. Now all the 4 sums are similar. The steps are similar. The method of solving is similar. Only the numbers are different. So here, since we have to determine means we have to see whether the points are collinear or they are not non-collinear. Now the question is, we have to see whether these points, point A, the coordinates are given, point B, the coordinates are given, and C, the coordinates are given. Whether point A, B, C are collinear, that is, they lie on a same line. Whether they lie, it's not necessary that all are collinear. They can be non-collinear also. So we have to just check. Now, last year in 9th standard, we have studied that when the points are collinear, okay, they lie on the same line, okay, and then we can write their betweenness. Okay, so in betweenness we have studied that for example, these are the 3 points, okay, then we can write that the 2 segments which are found because of the point in the center, when we add these 2 short segments, it is equal to the longer segment. Okay, so in that case the points are collinear. So if we prove here that from these 3 points we will get 3 segments, so 3 distances, distance AB, distance BC and distance AC. Okay, since there are 3 points, we can find 3 distances, again distance AB, distance BC and distance AC. So if we find that if one distance is equal to the addition of the other 2, then we can say that the lines are collinear. I hope you all understanding. As we solve, you all will come to know what I am talking about. So here we cannot write for now that which point A, B, C, where is the placement. Only thing, first we have to find their distances. So once we get their distance, then we will see whether addition of any 2 distance is equal to the third distance. Okay, and if it is the case, then we can say the lines are collinear. So in that case, first, now as I told you earlier, that it is not necessary that you have, when there are more than 2 points, you have to write x1, x2. Here, since there are 3 points, so I will show you one sum taking x1 and x2, and other sum I'll show you without taking these points x1, x2, how directly we are going to put the values. Now, but it is good to write x1, x2. So I will suggest you all to mention x1, y1, x2, y2 every time. How it has to be done? Now when we are finding distance AB, we will need only these 2 points, point A and point B. So in that case, we will take point A, x1, y1 and point B, x2, y2. So same thing I have written here. To find distance AB, let point A 1 minus 3b x1 y1 and point B 2 minus 5b x2 y2. Okay, by distance formula, first as I told you, we have to mention the formula. So square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. Now the second step is to substitute. So I have just substituted. Only thing, when we are substituting, see that be careful while writing the signs. If there is a negative sign, do not forget to write the negative sign. Okay, then we are going to solve. 2 minus 1 is 1. So 1 square. Plus, first we will solve this bracket inside with the signs. Minus 5. Minus into minus is plus. So minus 5 plus 3 the whole square. And minus 5 plus 3. It is a calculation of integers, so it is minus 2. We write the sign of the greater number and we subtract when the signs are different. So minus 2. So here minus 2. Now square of a negative number is positive and 2 square is 4. So it is positive 4 and 1 square is 1. So okay. So this calculation is a simple calculation. 1 square is 1. 1 plus 4 is root 5. Okay. Now this is distance AB what we have found. Distance AB. Okay. So distance AB is root 5. Now we will check the other distance, that is we will see distance BC and then distance AC. So when we are taking distance BC, we want point B and C. So point B we will take x1 y1 now, and point C we will take x2 y2. Okay. Same method. Finding the distance, write the formula and we solve. Okay, when we solve this is the calculation. We substitute. As I said that we have to first solve the inside signs. Minus into minus plus. Minus 4 minus 2 is minus 6. Okay, when signs are same, write the same sign and add. Now square of a negative number is positive. Okay, and 6 square is 36. 7 plus 5 is 12 and 12 square is 144. When we add this, here we get 180. First we need to add. Do not make a mistake of writing 36 as 6 outside and 14 as 12 outside. We have to add and then we have to take the, here you will see, it is 180. First add 180. Now 180 can be split in a multiple. Yes, it is 36 5s are 180. 36 is a square. Okay, split in such a way that we get a square inside. And if it is not possible, then you just leave it as it is with the root sign. So 36 into 5. So 36 comes out as 6. So 6 root 5. Now this distance is distance BC. Okay, this is distance BC. Now we got distance AB, distance BC. Okay, we'll just note it down. And then after this, we have to find the third distance, that is distance AC. So again, same method. Since we want point A and point C, we will take point A as x1, y1, point C as x2, y2. By distance formula, as I told you, please mention which formula. Okay, by distance formula, we write the distance formula. Here x2 is minus 4 minus 1 the whole square. Y2 is 7 minus 3 the whole square. When signs are same, write the same sign and add. So minus 5 the whole square. Okay, and plus, minus into minus plus, 7 plus 3 is 10 square. So this is, we have got. Now a square of a negative number is positive and 5 square is 25. So plus 25 and 100. First add inside, we have to do the addition 125. Now 125 can be split as 25 into 5. 25 is a square, so it comes out at 5 root 5. So this is distance AC. Now if you go back, you will find that distance AB we had found it is root 5. Distance BC we had found it is 6 root 5. And distance AC we have found is 5 root 5. Now 5 root 5 and root 5 is 6 root 5. Okay. So if you see here, 5 root 5 plus root 5 is 6 root 5. Because nothing is here in front, so it is 1. Okay. So 5 root 5 and 1 root 5 is 6 root 5. Okay. So here addition of these two distances, that is AC plus AB, is equal to BC. See here, AC plus AB, which is root 5, and 5 root 5 is 6 root 5. When we add distance of AB and AC, we get 6 root 5, which is the distance of BC. So here we have found that if we add two distances, we are getting the third distance. That means here which I had drawn this segment here, I can show you that if we add A is common, AB and AC. Okay, if we add AB and AC, you can see here. If you add AB and AC, so if we add AB and AC, I have taken A in the center because A is common. So if we add AB and AC, we get BC, that is 6. So AB was root 5. AC is 5 root 5 and together it is 6 root 5. This betweenness we had studied of 3 collinear points. Therefore, we can say that point ABC are collinear. Okay. So, point A, B, C are collinear points because the addition of two distances is equal to the third distance. Now, the third sum is, these are 3 points R, D and S, and we have to find whether they are collinear. Okay, same method. From these 3 points we will get 3 distances, distance RD, distance DS and distance RS. If addition of any 2 distances is equal to the third distance, then we can say that the points are collinear. So same method, we'll write here let or suppose. Okay. distance, in order to find distance. So first I'll write to find distance. Which distance we'll find first? RD we'll find. Okay, to find distance RD, okay, we will assume now let the point R 0 3 be x1 y1 and the point D, which is 2 and 1, be x2 y2. If you want, you can even write what is x1, what is y1, what is x2, what is y2. Okay, therefore by distance formula, okay, therefore by distance formula we have to find distance RD, which is equal to, first write the formula, x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to, now what is x2 here? 2 and x1 is 0 the whole square plus, what is y2? 1, sorry, don't put a comma. Okay, so y2 minus y1 the whole square. So here 2 minus 0 is 2 square plus 1 minus 3 minus 2 the whole square. Signs are different. Write a sign of greater number and subtract. Now 2 square is 4 and square of a negative number is positive and 2 square is 4. So it is 4. 4 plus 4 is 8. As I told you, if you are able to split it, yes, 4 2s are 8. 4 is a square of 2. So when it comes out, it will come out as 2 root 2. So this is distance RD. Okay, after that, we have to find distance DS. Okay, so to find distance DS, let this point D, it is 2 and 1, be x1 y1 and the point S, which is 3 and minus 1, be x2 y2. Okay, now by distance formula, first we'll mention the formula, that is ds is equal to x2 minus x1 the whole square plus y2 minus y1 the whole square. Okay, now we'll see what we have assumed, x2 x1. So x2 is 3. Please take whatever you have assumed, 2 plus minus 1 the whole square. Okay, here y2 is minus 1 minus and y1 is 1. We'll solve. Okay, so 3 minus 2 is 1 square plus, when the signs are same, write the same sign and add 1 plus 1 is 2. Okay, now further 1 square is 1. Square of a negative number is positive and 2 square is 4, which is equal to root 5. Now 5 we cannot split, that we will get a multiple, we'll get a multiplication of a square and a number. So we just leave it, distance ds. Okay, and now the last distance is distance rs. You can see a distance rs. Okay, so in order to find distance rs, again we have to, okay, so to find distance rs, what we are going to take, let this point R, that is point R is 0 3 be x1 y1 and point S, which is 3 minus 1 be x2 y2. Okay, therefore by distance formula by distance formula. We'll write first distance RS formula we'll write, and then we will substitute. So x2 minus x1 the whole square plus y2 minus y1 the whole square, which is equal to, here these are the 2 points. X2 is 3 minus 0 the whole square plus minus 1 minus 3 the whole square, which is equal to 3 minus 0 is 3 square plus, signs are same, write the same sign, that is minus, and add. 3 plus 1 is 4. Now again 3 square is 9. Now plus, negative sign, square is a positive, and 4 fours are 16, which is equal to 9 plus 16 is 25, and 25 is a square of 5. So when it comes out of square root, it becomes 5. So we have got distance RS as 5. Now since it is written on different pages, I will first mention all the distances so you can compare what we have found earlier. Okay, now this is we found here just now 5. RD we found earlier, which is 2 root 2, and DS is equal to root 5. Now can you see whether the addition of any two sides is equal to the third side? Can we add DS and that is RS, which will give us RD? Usually when two small numbers we add, we get the greater number. Okay, so can we add any two numbers that we can get the addition as the, so we'll just try here, the distance DS. If we add with distance RS, what is distance DS? Root 5, and RS 5. When we add these two distances, is it equal? It is not equal to distance RD. Okay, because it is not equal to 2 root 2. 2 root 2 is RD. Okay, so in this case, when we add the two distances, if it is not equal to the third, when we add the two smaller distances, if it is, the addition is not equal to the greater one, then we say that the points are not collinear. So in this case, we can write therefore, okay, points, that is R, D and S, are not collinear. Okay, we can also write with the coordinates as we had written. I hope this is clear. Now the first and the third I solved. So second and fourth you all have to do on your own. It is the same method. Follow the same steps. Find the distances. From these 3 points you will get 3 distances. For example, it's the second sum. First find distance LM, then find distance MN, and then find distance LN. Okay, and then when you find the distances, any two smaller distances, when you add, you should get it equal to the third distance, which is the greater distance. And if you are not getting it, then you will say that the points are not collinear. Okay, and at the end you have to mention along with the points and the coordinates. And now I told you that I will show you the other method in which you don't consider x1, y1, but see that both the sums I did by x1, y1 only. So even you all, when you all solve, see that you all do by x1, y1 method only. Okay, as I have done. So therefore, after this final answer, what you will write is points. When you write the points, mention their coordinates also. So what was the coordinate of R? R is 0, 3. So points R 0, 3. Then next point is point D. That is 2 and 1. And point S. I think point S was 3 and minus 1. Okay. Are not collinear. Okay. We'll end the answer.
So please revise whatever is taught in this video and write all the formulas which are taught in this video in your notebook. Thank you and have a nice day.